Hello students, today we'll discuss IB Math HL Paper 1 May 2018. Time Zone 1. I want to remind you that there should be no calculator, so don't show very accurate calculations. My name is Nariman Mealim. I am located in Baku. Here is my mobile and here is my email, so we can communicate. Section A. Question 1. So we're given function. We know that remainder, when we divide fx by x plus 1, remainder is 7, and when divided by x minus 2, remainder is 1. Find value of p and q. So if you divide function by x minus a, remainder will be value of function at this point a. Here a is minus 1, remainder is 7. Here a is 2, remainder is 1. So let's evaluate function at minus 1. It should be equal to 7. We find that p plus q equals minus 1. In the same way, value at 2 should be 1. So value at 2 is 1. We get another function. So we can express q in terms of p. So it will be minus 1 minus p. Substitute into this equation and get value of p, then get value of q. So question is done. Question 2. We have function. We should find derivative of this function. So chain rule. It will be 2 exponent goes downward 2 sine theta and derivative of sine theta. So with 2 sine theta cosine theta, nice way it will be sine 2 theta. Hence find the values for which derivative equals to y. So left side we already know, this is the left side. Right side is 2 and our function. Here you should not lose roots. This is why accurately move 2 sine squared to the left with minus, take 2 sine out of bracket. So product is 0 if one of the term is 0. So first sine theta equals 0. This gives us two solutions, 0 and pi. Then in the bracket cosine theta minus sine theta equals 0. We move sine theta to the right, divide by cosine theta, we get tangent theta equals 1. Solution is pi over 4. So we have 3 solutions. Question done. Question 3. So we conduct probability experiment with 2 dice with 4 sides, with 1, 2, 3, 4, and let the random variable t be maximum of these two scores. The probability distribution is given as the following. Right, find the value of a and b. So we should find probability. The maximum score is 2 or maximum score is 3. First we'll check why this is 1 over 16. So we have 2 dice. D1 has values 1, 2, 3 or 4. D2 1, 2, 3 or 4. Total number of combination is 4 possible cases here times 4 possible cases here, which is give us 14. Maximum score 1 is only for one case, 1, 1. So according to definition of probability, we divide number of successes by total number of outcomes. So here it is 1 over 16. Maximum score 2. So it's possible for combination 2, 1, 1, 2 and 2, 2. So 3 cases over total 16 give us 3, 16. So A is 3, 16. Maximum score 3. The first dice is 3, another second is 1 or 2 or 3. Or the first die is 1 or 2 and the second is 3. Maximum is 3. So no repetition. We have 5 outcomes, so it is 5 over 16, so B is 5 over 16. Find the expected value of t. To find expected value, we should add probability times value. Probability times value, probability times value, we get 3, 1, 25. So this question is done. So question 4, we should find, so we're given two different integrals, we should find another integral. So first of all, this integral we change into sum of two integrals. Second integral is very easy to find, so definite integral will be x, so 2x boundary minus 2 to give us 4. To find this term from minus 2 to 0, we subtract from minus 2 to 2, 0, 2. So we use given values, we get minus 2. Substituting minus 2 here and 4 here, we get 2. So this question is done. Then they ask us to find different integral of x plus 2. So we just change, we introduce new variable t equals x plus 2. Dx will be equals d2, but boundaries will change. When x is minus 2, boundary for t will be 0. When x is 0, boundary will be 2. So from 0 to 2 integral, and we see that this value were given just another letters, it doesn't matter. So answer is 12. Question is done. Question 5. Right, to simplify, what we should find, let's see. We should solve inequality, okay. Right, so I decided to introduce new variable t equals logarithm x. As a result, I have parabolic function, quadratic function should be less than 0. So graph will be upright parabola because coefficient is plus 1. And we should find these 2 points, roots of this quadratic equation. So a is 1, b is minus logarithm 2, c is minus 2 logarithm 2 squared. So we use standard formula for quadratic to find roots of quadratic equation, accurately substitute, and we get two solutions. For example, first solution minus logarithm 2. So we have logarithm. So to solve this, I just raised both exponent by both sides to get rid of logarithm. So I get this value, and the same I did here. As a result, I got two solutions. So our answer is strictly between them. Strong inequality, because at the beginning we have strong inequality. Question 6, very easy question. We should prove that this sum equals this expression using mathematical induction. So step 1, we check that it is true for n equals 1. So when n equals 1, the last term is 1. Actually, there is only one term, 1. And here we get 1, 3 over 1, 4 minus 3, so 1 equals 1, so it is true. Now step 2, let's assume that it is true for n equals k, so we rewrite this formula for n equals k and assume that it is true. Now we should prove that it is true for n equals k plus 1, so I rewrite the sum adding one more term, k plus 1, and the rest part I can change by this expression exactly. So now two last terms I want to add, so I add two last term, and here I make trick, I multiply and divide by 2 to get here 2k plus 1 minus 1. Here I already have it because 2 to the k is 2k plus 1 minus 1. So the same denominator, I add numerators, and I get this expression. So I put it and it is proved. Question 7. We have our cosine function. Our cosine, we should find first derivative. We use chain rule. So first we find derivative of function of something. So we look into the booklet. It gives us this -1 over square root. And we don't forget chain rule, so we should also find derivative of x over 2. So we have simplified this expression. Find integral from 0 to 1 of r cosine. For some reason they ask us to find derivative. Why? Because they push us to use integration by parts, where u will turn into u derivative. So so this is standard form. U is r cosine x over 2 and v is x. So we put everything accurately here. The only problem is to find this simple integral. So we replace 4 minus x squared with new variable t. So dt will be minus 2x dx. Minus 0.5 dt will be x dx. So x dx can be substituted with minus 0.5 dt. Then we have integral of exponent. We add 1 and then divide by total exponent, so we get this expression. So we found this integral. We know the indefinite integral, so we can put boundaries and find the value. So this question is done. Question 8. Let A be sine B, B between 0 and P over 2. Find in terms of B the solution of sine 2x equals minus A, x between P. So, if x is between P and 0, 2x is between 0 and 2 pi, and because A equals sine B, sine 2x equals minus sine B or sine minus B. So the value of sine minus B should be equal to sine of our angle doubled. We don't care about doubled angle, just some angle. Sine of some angle should be equal to sine minus B. So if this is minus B, this is the sine minus B. So it is possible for two angles, pi plus B and 2 pi minus B. So our angle 2x can be either pi plus B or 2 pi minus B. So solving, we get two solutions. So question is done. Section B. Question 9. So it should be done on separate paper. This is, I have solution in the end. Let's find the solutions. Here are my solutions. Okay, very good. Question 9. So we have function. The graph of function has local maximum. Find coordinates of A. Local maximum means that derivative equals 0. So to find derivative, I rewrite this fraction form into sum form and very easily find derivative. Then I equate derivative to 0 and find x equals minus 1. So x equals minus 1 and the value of function equals here minus 1 minus 1.5 give us minus 2.5. So point itself is minus 1 minus 5 over 2. Shows that there is exactly one point of inflection on the graph y equals fx. So point of inflection means that second derivative equals 0. So we find second derivative, then make it 0, and we find that this happens at this fifth root of 4. is 1, so we proved it. The coordinates of B can be expressed in the form like this. Find the value of A and B. So first of all, I rewrite what I found, coordinate of x, in this form, and it means that A equals 2 over 5. Then I evaluate function at 2 over 5 and equate it to B to this power. Then I take 2 minus 6/5 out of bracket. So, and what I have in the bracket is B, so it is minus 5. So we found B equals minus 5 and A equals 2/5. Sketch the graph showing clearly the position of points A and B. To sketch graph, I decided to care about vertical asymptote at x equals 0. So if we approach 0 from the left, it becomes approach negative infinity. If we approach from the right, positive infinity. If x tends to negative infinity, f also tends to negative if x approaches negative infinity. And also we care about maximum A and inflection point B. Approximately I put them. So this is why I put here values minus 1, minus 5, 1, 2. Right, so this question done. Question 10. So we have pyramid. This pyramid cuts x at 1, c at 1, d at 1, and it is square pyramid. And we should find Cartesian equation of plane passing through points A, B, and D. So let us do it. Here we are. Okay, so Cartesian equation can be written like this, where n are coordinates of normal. To find normal, coordinates of normal, we find vector product or cross product of AB and AD. To find AB, we subtract OB minus OA. The same with AD. Then we're using formula, very complicated formula with components W and V. But what simplifies this case? Many zeros. So as a result, we get this vector. So we put these coordinates as coefficients, and we need D. To find D, we take any point from the plane, for example, point A, substitute its coordinate, we find D. D is minus 1, hence we get this, and simplified we get this. So plane P2 passes through B, C, and D and is y plus z equals 1. Find the angle between the faces ABD and BCD. We are not going to find... okay, here we will use coordinates of normal, because angle between normals to these planes will be equal to the angle between the planes. So to find coordinates of normal, so one normal we found ourselves, another normal we see from the equation of plane. X is 0, so 0, 1, 1. So 0, 1, 1. And to find cosine, we dot product of two vectors by the amplitude. So cosine will be minus half, so angle is 120. So this question is done. Plane P3 passes through A and is normal to the line. Find the Cartesian equation of P3. So normal to line BD. So BD is normal, and we need equation of So BD give us coefficients of this plane equation, and we need D because it goes through Z, 0, O, so we put 0, 0, D equals 0, so finally we get the equation. P3 cuts AD and BD in points P and Q. Shows that P is midpoint of AD. So this is our plane P3, and point P is midpoint of AD. So if you look to the picture, you will realize its coordinates. Because it is on the plane, it should satisfy the plane. So we substitute and we get 0 equals 0. So point P is midpoint and is on the plane. So this is done. Find the area of triangle of PQ. To find, first we should find point Q. This time we will use more standard method. So the line BD, equation of line BD is point B, lambda, and segment BD. Right, so this is parametric equation of line. So our point Q is on this line and is on the plane. Plane is there, so we substitute point parametric equation, and we should find lambda. So lambda will identify the position of point Q. So this is the position. Lambda found, substituted, and we know point Q. To find area, we need half of cross product of OP and OQ. Again, you use booklet for cross multiplication. So P, O coordinates are this. So the question is done. Now question 11. So question 11 is about imaginary complex numbers. So they are in the modulus argument form. We should find second and third power of this. So we need Euler form. So Euler form of our function looks like this. When we square, 2 becomes 4, angle becomes 2 times more. When we cube, argument becomes 8. Here mistake, here should be 8. Sorry. Right, so done. Sketch these powers on Argand diagram. So we find them first of all. W0 is 1. Then, because you don't use calculator, approximate values. And what is interesting, every next power turned by 60 degrees relative to the previous. The 4 points form quadrilateral. Find the area of quadrilateral and show that it is like this. So if we draw quadrilateral, consists of actually triangles. To find area of each triangle, we need modulus of these triangles halved multiplied by sine of 60 everywhere. So we add, multiply, and we get this value. Let Z be, so this time pi over n, and we have 0 to the first, 0, Z to 0, Z to 1 from vertices. So polygon finds the area and shows that it can be expressed in this form. So again, it is sum of triangles, and we take sine pi over n out of brackets. Instead of 2 we have 4 raised to power. Here we have geometric progression. First element is 1, n elements, r is 4. The sum is, we can find from booklet. After substitution we get this expression. So a is 1 over third, b is 4. Question is done. See you next time.